Good morning to all of you. Before we start today's session, please feel free to do event check-in. This will give you access to additional resources and information about events that we are running on Reactor, which are around similar topics to today's session. I will share the event check-in link with the event ID in the Q&A section shortly. Also, we have launched our Reactor group on LinkedIn. Please feel free to join the group to get the latest update on session happening on Reactor. I will share the joining link soon. Thank you all once again for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 60 minutes including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel within 3 to 4 days. I will share the link to our YouTube channel in the chat section soon. Quick word on our code of conduct. We display this at all Microsoft Reactor events that we run, and it's just a reminder to be aware of others. The key thing to take out here is to be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Deepu, our speaker for today's session. Deepu is a solution architect with Microsoft Industry Solutions. He is focused on helping enterprise customer in cloud transformation via adoption of Azure and DevOps. But for now, I will hand over to Deepu to begin the session. Over to you, Deepu.
Thanks, Rashmita. Hi, everyone. Let me quickly share my screen. All right, I hope it's visible now. So let's get started. So as part of the Azure WellArchitected framework session today, we would talk about the Azure cost optimization as well as operational excellence. So my name is Deepu and I'm a solution architect with Microsoft Industry Solutions, and we, being part of the Microsoft Industry Solutions, help the customers adopt Azure DevOps and help them in their digital transformation and Azure adoption, right? So we work with customers in terms of designing solutions for them, implementing them, and helping them in running their day-to-day operations as well. So with that, let me quickly move to our topic today. So we'll talk about start with the Azure cost optimization. So there are different factors we consider as part of the Microsoft WellArchitected framework when it comes to the cost optimization. Now, if some of you are new to this Azure WellArchitected framework, it's basically a set of guidelines. I can actually show you that. Yeah, so if you go to the Azure Architecture Center, right, you can see the Azure WellArchitected framework. So it's basically a set of principles or guidelines that can be used to improve your quality of workloads. So it's again split across multiple pillars, what we call as the WAF pillars or WellArchitected framework pillars, including reliability, security, cost optimizations, and operational excellence, and performance efficiency. In the same Reactor platform, I think yesterday or day before, we had another session on reliability and security. Today, I will be covering the cost optimization and operational excellence in a bit, and then we'll have a session on performance efficiency as well. So with that, let me come back to my slide. And there are multiple considerations that we take into account when we talk about the cost optimization as part of the Microsoft WellArchitected framework, right? The first one, starting with capturing your cost requirements. It basically tells you start your planning or your Azure deployment planning or your Azure infrastructure planning, right? With careful enumeration of your requirements. So, and again, just make sure that all the stakeholders as part of your business are associated and addressed when it comes to this cost requirements. Again, this can be done at multiple levels, including your business workflow, your compliance and regulatory requirements, what is your security requirement, what is your high availability and disaster recovery requirements, etc. Because all of these considerations have a trade-off with cost. You can go ahead and implement a very robust solution, having absolute zero downtime. But at the same time, we need to see whether the budget allows for that, and do we have a real business requirement for such a solution, right? The second thing talks about the initial cost estimation that you can do as part of planning your Azure infrastructure or your cloud footprint. So there are tools like Azure Price Calculator or Azure Total Cost Estimator, wherein you can actually view upfront, right, the amount of cost that is going to get involved when you provision certain infrastructure resources. Say, for example, let's take an example of Kubernetes cluster, an Azure Kubernetes cluster or AKS, right? So like when we have this design in place, we would be thinking, okay, we have an Azure AKS thing, it would have come with a certain cost, etc. But there are a lot many configurations you can do on the Azure AKS service or for any resource in Azure for that matter, right? There are different SKUs available. There are different bandwidth limits that you can apply, etc. So if I take again the typical example of Azure Kubernetes server, then you would need like the cluster. You would need to like visualize like, okay, what would be my requirements or my scalability requirements, whether I need 1 node or 3 nodes or 10 nodes, right? So if I go with 10 nodes, what would be my cost consumption, right? And then we have things like, okay, how can I secure the ingress traffic to my application gateway? Can I use something like an Nginx, or can I use something like an application gateway ingress controller, which would again incur additional costs for your application gateway, then your load balancers, then the ingress network charges, right? And what about any backend services like your databases or any storage services? So all these things involve certain costs. So it's always better to have this cost estimated upfront so that you can always go back later and like map it exactly, like why this cost difference is there. Is there something which I didn't consider as part of my design, etc. So this is something which we typically do with every customer as part of the solution we build. We also try to create a cost estimator for the customer to let them know upfront, right? Like how much cost these resources are going to incur. The other point to consider is the consumption-based scalable costs. So again, in Azure, like as you all know, like you are charged for the resources that you consume, right? But that being said, like some of those resources come in certain blocks of size only. Say, for example, a virtual machine comes with a predefined size, right? And whenever you don't need that extra capacity, it's always better to go for some like a scalable architecture, scalable solutions. Like the example I told, whether you need a web app or like a AKS cluster, it's always better to have the auto scaling configured so that you would be getting charged for those extra resources only at the time of that peak usage, right? And the most important thing is right resources and right size. So this is where we always see massive improvements for customer environments where they can reduce or optimize the costs. Especially when it comes to lower environments like dev and QA kind of environments, because people tend to, there may not be a lot of guiding principles or policy governance applicable in those environments, and people tend to provision resources or like over provision resources there, right? So it's very important to make sure that you have the right size. Say, for example, if your application requires say two CPU cores and 4 gigs of memory. So you can have your virtual machines or your PaaS instances configured with sizes around that, rather than over provisioning it and then later figuring out that, okay, I'm paying extra for the services, right? So it's always better to start small in lower environments, see how the utilization is, how the performance is, and then better you can scale it up. Again, right resources. By right resources, what I mean is like sometimes a simple database solution can be hosted in a PaaS solution, which can be very cost effective compared to running that solution in a full-blown virtual machine as such, right? Or some of those applications can be run in like serverless functions, Azure functions, and things like that. So where you may not need to pay for the entire cost and the management overhead of a particular virtual machine as such. And monitoring and optimizing this performance is also very important. So we have tools like Azure Advisor. So I'll get into that in the subsequent slides, which will give you recommendations in terms of how your resources are doing good so far, or doing good or bad so far in terms of the cost optimization, right? And you have tools like Azure Cost and Azure Budgets, etc., where you can set monthly limits and alerts to make sure that you are not hitting those like budget limits. Right? And the last and the most very important point here is about the governance. So when it comes to governance, basically like every team member or every department as part of the cloud operations or usage should be aware of the cost implications. And there are multiple things that we can configure or options we can configure in Azure to make sure that the resources are getting aligned, or the Azure resources that you are getting aligned are, the Azure resources that you are creating are getting aligned to the overall business strategy for cost optimization. Say for something like tags, you can implement tags and make sure that each department or business units are getting aligned to the tags, and you can see what kind of consumption they are consuming, and we can perform cost optimizations there. We can implement Azure policies and other kind of controls in place to make sure that we are only provisioning the required amount of resources in the required region, right? So say, for example, one specific resource, it may have different costs in different regions, right? So all these things can be controlled with the governance. So you can get a lot more a lot more in-depth details about these different items as part of the WAF framework. So I just showed you that page where you can go into and drill down into specific details of cost. So if we go back there. So this is the cost pillar, cost optimization pillar for the Azure WellArchitected framework. So you can have a lot of resources here. You can have some learning plans. You can watch some videos, and there are some pretty good articles which will help you how you can manage the cost in Azure. Right? You can drill down into each of these specific items and have more detailed insights there. Now, in this session going forward, I will be talking about two important things, or two major ways you can save cost. There are a lot many. I'll probably try to cover some of them more in the last slide. But predominantly, I will talk about the Azure Advisor recommendations, what recommendations it gives, and how you can effectively optimize your cost using like Azure Reservations or reserved instances, as well as like you downsizing or shutting down your virtual machine instances, etc. Now let's quickly start talking about the Azure VM Rightsizing. So this is a typical snapshot you would see from Azure Advisor. So I have multiple subscriptions as part of my tenant, and then when I open my Azure Advisor, I'm seeing the following recommendations, right? In all these different square boxes, I can see those recommendations. And if you closely observe, these are exactly aligned to the WAF pillars I told in terms of cost, security, reliability, operational excellence or DevOps, and performance, right? So in this specific snapshot, you can see that I have 5 recommendations on my cost, then some 50 recommendations on security side of things. To improve my reliability, there are 3 recommendations, and for my operational excellence, I have some additional 6 recommendations. And from a performance point of view, I'm doing good so far, so I don't see anything here, right? So in the interest of this session, we will deep dive into the cost piece of it, right? So let's go deep. One level down. So when you get into the cost recommendations from Azure Advisor, right, you will be getting multiple options here, and the potential savings are also being listed here. So what it says is like out of all this, if you go ahead and address these 5 recommendations, you can potentially save up to $200,000 a year, right? Or if I go to something like a right size or shut down underutilized virtual machines, I can save something close to 12,000 or 10,000 US dollars, right? So these are different recommendations that Azure Advisor would give based on the resources that you are already running on Azure. So here I can see in this case, because I have around 120 virtual machines, right? Where it is giving me like I have in my subscriptions 120 virtual machines, where the advisor is giving me a recommendation to go ahead and purchase reserved instances or reservations, right? Similarly, for my 18 virtual machines, it's asking me to try right-sizing or shutting down the virtual machines to save some cost there. So let's again look into this right-size or shut down the underutilized VMs and see what it refers to. So in this specific example, right, so there are multiple cost-saving options being mentioned here. So I'm just highlighting only one of that. That's for one specific virtual machine. So it is saying like overall I can save around 12,000 USDs. Out of that, like this around 10,000 US dollars savings can come from one single recommendation, right? And that's not bad for a single recommendation. It's quite a good amount of saving. And what it recommends is you resize your standard D16 virtual machine, D16S V3 series virtual machine to a D4 series virtual machine. So, or in other words, what it is asking me is like downsize a 16 core virtual machine, right, where I have 16 CPU cores to something which has only 4 cores, so that you can save some cost there. And the basis of this recommendation is that the CPU utilization is less than 5% and something like that. So we'll get to see how these recommendations are produced and how we can utilize this. So this is the current utilization for that particular virtual machine. So if you see here, this is again D16 virtual machine. And in the graph, you can see 3 different metrics that I'm monitoring. One is the CPU, which is in the light blue color. Then I have the network with the dotted lines and the memory in the pink color, right? So if you see the overall utilization, none of these metrics is actually crossing something like, okay, I see just 28% here. So it's not crossing 28%. Even that 28%, if you see, it's like a short spike from the CPU, right? So it may be something around like 15 or 20% of utilization altogether. But for this virtual machine, I have provisioned already 16 cores and 64 GB of RAM, probably assuming that my application would need that much of resources, right? So when we so what we can do here is like we can again drill down to specifically to the telemetry of the percentage of CPU, memory, and network utilization. And this chart again shows it for the last 7 days from 13th of October to 13th to 20th, right? So and this is the same amount of metrics that you are going to see if you are logging into this virtual machine. Let's assume that this is a Windows virtual machine, and if you go to the performance counter, this is the same set of metrics or like telemetry that you get. And Azure collects this at all from the host level, from the hypervisor level, without getting into the specifics of your application. Or we really don't have any specific idea of what kind of workload you're running in this application and in what context these VMs are getting used, right? So all these metrics are being pulled from the underlying platform. And in this example, this has not crossed 28% in the past 7 days. And if you see this shaded portion, right, this red shaded portion is the underutilized portion, or this shows the portion of the resources which is not being utilized by this virtual machine. So, or to put in another word, more than 70% of the resources that I have provisioned for this particular virtual machine is not getting used, right? Or even in other words, the workloads that I am running on this virtual machine simply doesn't need the entire power that I have provisioned or the entire resources that I have provisioned for this virtual machine. So let's have another look at the underutilization, right? Sorry. Let's say that this is your CPU utilization for the past 1 week or 7 days. It's consisting of metric values from every half an hour for the past 7 days, which means like I have something more than 300 data points here. So for the ease of analysis, we take a 95th percentile of all these values to base our calculations. So when we take the 95th percentile, it basically considered most of our high load, while it neglects those typical spikes, right, which we saw in the earlier screenshots. So net, it will give you something like a proper CPU utilization when we take that 95th percentile. And in this case, the 95th percentile corresponds to something around 10% of the CPU utilization. So which means I have still my 90% of my capacity being underutilized. So when it comes to memory, the calculation that we do is on the 100th percentile. So there is a difference here because why we are not taking the 95th percentile is because most of the applications can actually tolerate CPU spikes or like unavailability of CPU cycles for like a short moment. But when it comes to memory, most of these applications are sensitive and there can be like a memory exception errors and things like that, right? So that's why we take the 100th percentile here to make sure that we are taking into account of those spikes as well. So which gives me a memory utilization of something around 9% for this virtual machine, right? Now there is a different way of representing it. It's something we call as buckets. So what we are doing here is this particular 95th percentile of my CPU utilization, which is 10%, we are mapping it to a bucket. In this bucket, I'm using probably only the bottom 10% of it out of the 16 cores, right? And similarly, my memory looks like, okay, I'm using the bottom 9%. So now this empty space, right, in the bucket represents the underutilization. Now, for the right size recommendation, what we need to understand here is like assuming your workload is fairly constant. What we will try to do here is like move these resources to a different, smaller or cheaper bucket such that your empty space in the bucket is minimized. So while still you will have this much of capacity available in the smaller bucket, but what we are trying to do here is like we are reducing this underutilized capacity or portion of the bucket, which is shown in the black color here, right? So let's see how we do that. So I have 16 cores. Then I have the 10% CPU utilization. This is the standard D16 bucket that I have. Now, what I'm trying to do here is, assuming this workload stays fairly constant, I'm actually trying to quadruple the utilization here, right? By using a bucket which is only 1/4 of the size. So instead of 16 cores, I'm using a 4 core, and instead of 64 GB, I'm using a 16 GB. Now my utilization has come down drastically. My CPU utilization, my underutilization has come down drastically. Now I'm able to take up to 40% of my CPU here and up to 36% of memory here. Now, if I go down and reduce it to even half, right? So I have now 2 cores and I have 8 gigs of memory, which is my D2 series or D4 series, right? So there I can go up to 80% and 72%, or in other words, I am just wasting only 20% of the resources here compared to 90% resources in the first bucket, right? So this is the basis of the calculation that we do for right sizing your workloads. So again, the large variety of SKU sizes that we have in Azure helps us provide that we have enough sizes to choose from as part of our recommendations. Now I'll bring the concept of targets here. So let's explore how we land on those specific sizes, right, that we show in the Azure recommendation. One of the previous slides you would have noticed for my D16 series virtual machine, it was giving a recommendation to like scale it down to D4, right? So let's see how those recommendations are arrived at. So it's all based on the targets. So what we try to do here is we want the ideal maximum utilization to be and try to choose a specific size that will get the utilization closest to the target. Now, you would see there are 2 types of like targets that we have set here, user-facing and non-user-facing targets. So the user-facing is something which your which refers to your proper workload that is directly processing a request from a user, right? And a non-user facing target represents or implies a workload that may be processing some backend jobs, like something like a batch job or scheduled job and things like that. Now, since these user-facing targets are more, or user-facing workloads are more critical in nature, we give it a lower target, right? Like 40% of the CPU and 60% for the memory. While for the non-user-facing targets, we can say that, okay, it can go like up to that 80%, right, for the CPU and memory. So that's how we set those targets for the user-facing and non-user-facing specific workloads and targets. Now, the interesting question would be, how would we know whether there is something user-facing or non-user-facing traffic, right? As I mentioned earlier, we don't get into the details of what exactly is being provisioned or what exact applications are getting provisioned in the workloads and for what contexts that are being used, right? But that's something which Microsoft Research has done some interesting research and learned that it was possible to determine whether a VM is running sort of user-facing or non-facing workloads by looking at the average load pattern for that particular virtual machine. So this was published in the research, and if you are interested to learn more about that, you can refer this. So it will give you a better insights of how we are identifying those user-facing and non-user-facing workloads, right? Now, since we have done all these calculations, and let's see how the Azure Advisor is going to give us a sizing, right? So first, we collect all these metrics in terms of your CPU, memory, and network telemetry data, which again, we retrieve from the underlying Azure host platform. And it's completely anonymized data. We don't take any customer specific data from that. It's only those metrics utilization. And it doesn't have any context on what workload is being run in those specific virtual machines, right? And this data is sampled every 30 seconds and aggregated over 30 minutes using those maximum values for aggregation. And then we look at that 7 days of utilization of telemetry data to create this recommendation. So if you have a virtual machine which was provisioned a couple of hours back, then probably you will not get this recommendation because it would take its own time to have this metrics collected, the data sampled, and then the utilization telemetry history is considered, and then it will arrive into the recommendations, right? So what happens here is we actually compare the current utilization versus the capacity or what the actual virtual machine is capable of, right? And then we identify the user-facing and the non-user-facing workloads and set the targets accordingly. Then we will consider a solution that works for all these 3 different metrics, which includes your CPU, memory, and network, right? And if multiple options occur, say, for example, for the same CPU, memory, and network, the recommendations comes down to, say, for example, 4 cores and like 64 GB of RAM, etc. So if there are multiple queue sizes and options available, the Azure Advisor will recommend you the cheapest option, right? And in all cases, we ensure that there is not going to be any performance or reliability hit to these workloads after adopting these recommendations. So basically, you are just making sure that you are cutting down those underutilized resources. So this is what we saw for a D16 VM, right? So the utilization was somewhere around 28% with D16. But after we apply the Azure recommendations and downsize it to a D4 V3, which has 4 cores and 16 GB RAM, you can see that I am able to use up to my 75% of the capacity, or in other words, I have only 25% of my capacity, which is underutilized, which can be used for like spikes or scaling my workload, etc. Right? So net to net, I'm seeing more than 75% cost saving here, right? So this is one of the beautiful features that you get from Azure Advisor out of the box, where it will go and look at your existing resources and will give you cost optimization. And again, this is not just only for virtual machines, it gives you for other resources as well. And I would highly encourage you to go ahead and have a look at Azure Advisor recommendations or the documentations around it to see what all cost savings recommendations it gives for the resources present in your environment. Now I will talk about Azure Reservations as well. This is another option where you can like have tremendous cost savings. So again, I'll just go back to my Azure Advisor, and I am in my cost pillar or my cost recommendations here. And I'm now looking at a different recommendation. So what it says here is for your 120 virtual machines, or the applicable 23 virtual machines, right, in your subscriptions, go ahead and buy the Azure Virtual Machine Reserved Instances, or something we call as Azure Reservations, to save money over the pay-as-you-go cost. So how it works is, like, say, for example, you have some workloads which you know that you're going to use for years, like for the next 2-3 years, or next 3 years, 5 years, I'm going to run this workload in Azure. Then if you choose this option of reserved instance, where you are basically informing Azure upfront that, hey, I'm going to use this server or this particular virtual machine for the next 1 year or 3 years, etc., then there can be some cost discounts applied to it. And this is the potential savings that you see here. For these virtual machines, if I go with the reservations or reserved instances, I can get maybe up to like $200,000, right? Or overall, if I go with all these recommendations, I would get this specific savings. So let's have a look at what's the difference here between your normal pay-as-you-go instance and your reserved instances, right? So normally when you create a virtual machine in your Azure for the first time, or a new subscription for the first time, etc., you typically go with the pay-as-you-go instance, which is the default choice, right? Now there is this option also for you to have reserved instances. Basically, if you have those consistent virtual machines, right, which supports usage of reservations, buying Azure reservations from Azure will give you the option to reduce your cost. So when you continuously run this virtual machine instances without a reservation, you are actually charged at your pay as you go instance, right? Your hourly rates, right? But when you buy a reservation, what happens is like you immediately get that reservation discount because you are making an upfront commit to Azure saying that, hey, I'm going to use this resource for the next 1 year or 3 years, so that the discount is immediately available for you. And then these resources are no longer charged at the pay as you go rates, right? So that way it can help you save money by committing to 1 year or 3 year plans for multiple products. So for your dev and test environment kind of things where you constantly deploy and delete resources, this may not be applicable. But for just assume your production workloads, right, where you are planning to run them for a longer time, you have maybe some public facing applications or other internal applications which you want to run for a longer time. So this would be a right option because there are like multiple benefits you get out of it. When you compare a pay as you go instance to a reserved instance, it's all the same in terms of your configuration. For the same SKU size, you would be getting the same amount of memory, RAM, and other parameters extra, right? And you would get the same reliability or availability, right? Whether it is in terms of like high availability or like like across region availability, etc., it will give you the same reliability. And performance is also the same because we are not changing anything for this particular virtual machine. So it is going to give you the same performance. And the major differentiator here is the cost, and it can give you up to 75% cost savings when you go for a reserved virtual machine instance. This helps you again save money by committing to your 1 year or 3 year plans for multiple products. So let's see how this can help you. So the first thing is like it can give you, as I mentioned, like a huge cost saving when you do that upfront commit. You can even pay that in like one shot, or you can pay it in yearly or like monthly billing cycles you have when you make that commit. And you have that immediate discount, right? You don't have to redeploy or resize your resources which you have already provisioned. So the moment you enable the reservations, it would get applied for those resources as well. And you have the option to commit for 1 year or a 3-year plan. And if you look at it from Microsoft side or Azure side, it's a win-win for us as well, because we know that, okay, from this specific customers, we are seeing a capacity requirement of X amount of cores or like other specific resources for said one year of time or 3 years of time. So accordingly, we can plan our capacity plan in our Azure data centers and regions. Right. So it's a win-win for both sides, wherein we will be able to optimize our capacity planning, and for the end customers, they will have this huge cost saving. Now, there are a lot of points actually that go into this recommendation system. So this takes into account multiple factors to generate those recommendations with the projected usage and your potential savings. Firstly, it looks into all your currently deployed virtual machines and take a list of it. And say, for example, if you're using automation to shut down your virtual machines regularly, right? Then this simulation won't work here because you are already using some mechanism for cost saving in terms of you like shutting it down and like bringing it up in proper intervals. Thereby, you are not planning to run it continuously as a production workload or something. So in those cases, it may not be applicable. The simulation won't find any saving there, and there may not be any purchase recommendation for those scenarios. Right? And they will also look at the customer on-demand pricing, like the kind of enterprise agreement that the customer have with Microsoft and the regions where the resources are deployed, etc. Then it will look into the aggregate usage, like the performance counters or the metrics for the last 7, 30, 60 days, etc. It will take into account those specific usage patterns. And it will also look into any recent reservation purchases are there, right, for you to get the right benefit. And it will look for each of the subscriptions under your enterprise enrollment, right? And based on all these different like combinations or different recommendations, it finally brings in specific recommendations with the projected usage and a potential saving. Something like which we saw earlier in one of the snapshot, where it was saying, if you go with my reserved instance purchases for 23 virtual machines, I can get up to $200,000 save, right? So these are the kind of data that goes into this recommendation. So hourly usage data for the past 7, 30, 60 days are taken into account. So it actually simulates the cost with and without reservations, right? And it simulates the cost for different quantities, like something like 1 virtual machine versus 10 virtual machine versus like 100 virtual machines, etc. Then it recommends a quantity that gives you the maximum savings. So whatever recommendation that you see on Azure Portal, that is the one which is going to give you the maximum cost saving. Though you can always go ahead and modify it and do it according to your choice, but it's always recommended to go for the recommendation that you are getting from Azure, because there's a lot of this kind of cost saving calculations that are being done in the backend. Right. And if you see in this specific chart, my VM usage here, it fluctuates somewhere from 35 to 70, right? So for some days I have like 35 VMs in my subscription. Some days I'm having 70 VMs. So what Azure Advisor or the Azure Reserved Instance recommendation would be giving you is like to go for 45 virtual machines with reserved instance or reservations, right? So this will maximize your saving, even though you may not be 100% there, right? But what it says is like, hey, you are already bare minimum using 35 virtual machines, and you are picking up to 70 virtual machines occasionally. So why don't you go and purchase that capacity for 45 virtual machines so that you can have the cost savings for this 45 virtual machines. So how do I get these reservations or reservation recommendations? So these comes from different options, different places. I would say one is the Azure Advisor. As part of your Azure portal, you can go to your Azure Advisor and look at the cost pillar recommendations. You would see the Azure Advisor recommendations for purchasing the reserved instances. Then you have an option in the Azure portal. So if you just search for reservations, you have an option to go to the reservations page and you can purchase there. It will show the recommendations. Then there is this cost management Power BI app, and you can always use the Azure APIs to query the recommendations. So recommendations are again available. It's better to go for 3-year recommendations, right? And wherever it is not available, it's a 1-year recommendation. And you can purchase as many recommendations as you want, but the recommended amount or the recommended amount which showcases in the Azure Advisor or the reservation portal is something which is going to give you the cost benefit. So that's pretty much about the Azure reservations. Now I'll quickly, in this interest of time, I'll quickly walk through some of these different other cost optimization tips that you can use. We have seen the Azure Advisor and reservations already, but there are a few others we can cover. So one is that the tag everything. This is something which we recommend as a practice, even as part of your deployments, even if you're using infrastructure as code or manual deployments, etc. It's always recommended to tag your resources with meaningful tags, right, which can associate them back to some specific business units or projects or organization units, etc. So that way we can always keep a track of what is happening like with this specific tags. When I do the run the cost analysis against the specific tags, I can see like which particular department or project is incurring the most of the cost, and then we can drill down into details and see which specific resources or resource groups are consuming that, right? And another important aspect is the automation. So that comes in different forms. So the plain simple automation is to just shut down and like use those resources only when it's needed, right? You can have those schedule the shutdown window for your virtual machines so that you can keep that shutdown when that's not required, so that you don't pay for the CPU and memory costs or network costs. You are just paying only for the storage at that point of time. And again, if you are looking at something like a sandbox environment kind of things where you deploy multiple resources together and then you do some testing on it, and maybe like over the weekend, you may not need all those set of resources. There can be some 20, 30 resources, right? So some of them probably you may not be able to delete them, keep them shut down altogether, right? So in that case, it's always better to use some automation using infrastructure as code and pipelines and things like that, which I will cover to a small extent in my next session. So you can use those pipelines and things like that. So you maybe like, let's assume the case of Friday evening, right? You don't need those resources for Saturday and Sunday, and you can always start, if you can always start fresh from Monday. So it's better to schedule those pipelines to run on like a Friday evening so that it will go ahead and automatically delete those resources. And you can even get that scheduled to run on Monday morning. So by the time you are back to work, all those resources will get deployed once again, right? So there are different, again, automation is a very big topic. There are different things you can do there for cost saving as well. Now, the other important factor is you consistently monitor your cost, including the Azure costs and using Azure Monitor solutions, right? Like your Azure costs, or you're setting your Azure budgets, etc. Looking at the monthly bill, setting targets to make sure that you are getting alerted and things like that. The next thing is you go for auto scaling, where you are actually paying only for the capacity when it's absolutely needed. Otherwise, your instances will be running with bare minimum required scale. And when the resources utilizations are higher, it may go for a higher scale resource. And resources queues are also very important. So like the way we saw in the previous example, like a D16 versus a D4 VM can bring subsequent cost savings over a period of time, right? Similarly, there are different resources types as well. Say, for example, for my dev and like testing workloads, I don't need to use something like a virtual machine with a premium disk, right? I can go with something like a normal standard disk, or even I can go with something called Azure Spot instances, where you may not be guaranteed that capacity, because whenever Azure needs that extra capacity, it can take that. But if you are okay with such a kind of an environment for your dev or lower environments, you can go for that. Or even you can go for burst series VMs, right, where your CPU cycles are not completely guaranteed, but your applications may perform a bit slower. But if that is sufficient for you to use in your dev and lower environments, it's definitely recommended to use that. And the last piece is the hybrid benefits. This is typically applicable for Microsoft licenses when it comes to operating systems, SQL Server licenses, etc. So if you already have purchased some on-premises license, or have the software assurance thing, so you can use this hybrid benefits to make sure that you are saving on your license costs and paying only for the actual hardware resources, right? So that is pretty much I wanted to cover on the cost optimization. I know it's a small, I probably talked about a lot of things in a short span of time, but I would definitely recommend you to go ahead and read more about the cost optimization as part of the Azure WAF or WellArchitected framework. And here are a couple of links which helps you better understand the reservation and how it can be used effectively. With that, I think I can spare a couple of minutes for any question before we jump on to the next session.
If you have any question, you can please unmute and ask question to Deepu, or you can as well drop your questions in the chat section.
Hi, Deepu. Thank you so much for this valuable session. I had a question. This is in regards to the vendor lock-in. So a lot of customers these days, they want to avoid the vendor lock-in. I know Azure Reserve instances can help you save a large amount of money. Considering like 120 VMs, we were able to save around 200,000 US dollars or Indian rupees per year. But that's a big amount. So what do you suggest on this? Like, how do you communicate with the customer in that way then? Because most of the customers are using multiple cloud providers, and they want a hybrid solution. Right.
Got it. As you rightly mentioned, most of the enterprises customers whom we talk to today, right, they are running this multi-cloud strategy. So they may be running one portion of, it's like that proverb, right? Don't keep all your eggs in one basket, kind of thing, right? So some of those workloads would be hosted in Azure. Some of them would be hosted in like other providers like Google or AWS, etc. Right? So again, it to a large extent it depends on what exact strategy the customer also follows, because there are some customers who use Azure or one cloud service as their primary cloud solution, right? And the second one as their backup mechanism in case if something goes right. Okay, I can switch back these resources to the other cloud provider. But there are few customers who go with like using both side by side. So I have a like highly available solution. If one Azure region goes down, I can bring it from my other cloud services immediately, right? Those kind of things. So this is again, see, this reservation, what we are recommending them to use is like, it again, to a large extent, it depends on what is the disaster recovery scenario, right? If there is an Azure disaster in one specific region, what is their DR scenario? If they want to still have the resource running in another region in Azure, then this reservation is completely applicable. It's perfectly fine, right? Because you are still getting the same benefit. Now, if your plan is to switch it over to another like cloud, etc., then there is a trade-off, right? Because essentially, see, the thing is, when you commit to for this particular initial commit and you're telling like, hey, I'm going to purchase 25 queues or 25 number of reserved instances for this series of VMs, you are making that commitment. But in case if you are not maintaining that commitment, then it will be adjusted in your billing. So I'm not sure if we can call it as a vendor lock-in as such, but the idea here is to make sure that at least for your long-running workloads, right? If you have a proper DR strategy within Azure, we definitely recommend to go with the reservations itself.
Great, thank you so much. That was helpful. Thank you.
Hi Deepu, this is Manish actually. I have a question on whenever we talk about that cost optimization, we always talk actually I have seen some of the session, and in most of the session when we talk about cost, then we always talk about the VM that decrease the size and decrease the number of cores and decrease the RAM. But actually I want to know means how can we reduce and how can we see the cost aspect for other resources like we have an application gateway, which is a very costly resource like express routes and load balancers. So how can we address the cost which is incurred while using these type of Azure services?
Correct. Got it. So yeah, some of these services, right, like as you rightly mentioned, application gateway or load balancers doesn't come with this feature of reservations or like this kind of dynamic scaling, etc. Though application gateway gives you dynamic scaling because you can choose your scaling instances, right, from I think 10 up to 20. I don't exactly remember the number, but the application gateway gives you that flexibility for configuring that scaling. But as a resource, it cannot be shut down. Right. So as a load balancer, so if you see most of the networking services in Azure, it cannot be shut down as such. You have to keep it running. The idea here is to have auto scaling configured wherever possible, right? And second thing is like, as I mentioned earlier, you start with the lowest queues or resources to begin with. And then based on your usage pattern, you scale it up. Because say, for example, if I have a consistent 1 GB throughput across my networks, right, then I would maybe require an app gateway of specific queue size, right? Which doesn't mean that I need a app gateway maybe like 1 or 2 queues higher because my workload doesn't cater to that much of a bandwidth usage. So that trade-off is always there because when it comes to some of these resources like networking, etc., you cannot keep them shut down. You have to keep them running because those are like your core components. The other way to handle it is, but again, it's I won't recommend. It's a workaround, I would say, is to use automation to kind of delete and reprovision those resources when not required, right? But when it comes to this kind of core foundational components like networking, it's not possible because you need to have that service all the while. Does that answer your question, Manish?
Yeah. Thank you for answer. Thank you for your answer. And one more question I have. Suppose I have a hybrid scenario, like some of the services I have, some of the components I have in Azure, and some of the component I have in that on-premises. And so, in that case, would that Azure Advisor will advise me to save my cost?
No, Azure Advisor will not give you cost recommendations for any hybrid workloads. Hybrid workloads in the sense like workloads running on your on-premises. It will look into only the resources part of your Azure subscription.
Okay, yeah. Thank you. Thank you.
Yeah, Deepu, Christian here.
Yep.
I have one question. Could we give any use case how to select proper resources and its size based on our workload that could give us a good view on
Yeah.
that?
So again, sorry, getting some echo. If you could mute. Yeah, thank you. Yeah, so a couple of things. One is like from your application perspective, if you know already like what kind of CPU, memory, or other network requirements are there, right? For a specific application, it's easy to size that. But there can be some cases where you migrate your applications from on-premises to Azure, right? And you may not be knowing this application or particular server would have been running for years, right? And you don't know what the exact requirement. So in that case, like tools like your Azure Migrate and things like that will give you those recommendations. So if you're planning for a lift and shift or kind of migration for those virtual machines, we can get the exact sizing recommendations which Microsoft provides. This is again based on the history of the performance counters from those on-premises workloads. So the Azure Migrate will look into those specific components and see what's the usage and then get into the recommendations.
Okay. Any specific article or resource you recommend?
I can share that in the chat.
That will be great.
All right. Guys, I'm sorry. I think I'm just in the best interest of time. I didn't know if we spent this much time on this. So let's move forward. And I'll try to take any questions towards the end. Right.
Deepu, I have one question.
Yeah.
So do you have flexibility to change the VM size based on the advisor in reserved?
Yes, definitely you can do that. The only thing is like it will incur a VM reboot, but you can definitely change the size.
In reserved category.
Sorry?
Reserved VM size category.
Yeah, reservation is something which you are getting, you are buying that for those specific VMs, right? So that is still applicable.
Okay, thanks. And what is the feature that we can be used in terms of scheduling these VMs in non-business servers in Azure?
So you can use Azure Automation. That is one option. So if you want to keep your VM shut down during non-business hours and get them started, right? And then again, get them shut down. There is something called Azure Automation that we can use to do that. Or if you want to completely redeploy, like delete and redeploy, you can use things like your Azure pipelines, GitHub Actions, and other CI/CD tools.
Okay, thanks.
All right, Rashmita, I'll move to the next session. I know we are running a bit short of time.
Yes, sure.
All right. Okay, so in this session, I will talk about the operational excellence piece of the WAF pillars, right? I will quickly move to the next slide. So the operational excellence, when it comes to operational excellence from WAF, we typically look into multiple angles. One is application design, how your applications are designed for keeping those DevOps best practices in mind, right? Including pipelines and various kind of deployments, monitoring and stuff like that. Then you have the monitoring, something which all these customers are doing for years, but enriched with the specifics of those specific applications running in the cloud. Right? And then the application performance and management, like it basically talks about your application's performance, then the availability, multi-region availability, failures, and all those things, etc. And how all these things can be managed via DevOps. And the third option is about the code deployment, like what are the patterns you follow for your code deployment into Azure or your production environments, etc. Are you doing some sort of canary deployments or A/B testing and things like that? How frequently are your deployment cycles, etc. Then another thing is the infrastructure provisioning, or something which is known more frequently as infrastructure as code, which I'm going to touch up a bit more in the next upcoming slides. So this refers to the best practices for deploying the platform assets, right? Your infrastructure resources assets where your application will run. And the last is a no-brainer. It's a testing, which is very fundamental to help us prepare for any unexpected mistakes or to catch any mistakes before they appear in production or they make an impact to the users, right? So most of you are already familiar with Azure Portal. So like one of the first things that probably when you got your hands onto Azure Portal is like trying creating something like a virtual machine, right? In this example, I'm just trying to create a virtual machine. I'm just filling in all these different sections with all this information. And the last stage is review and create. So when I review and create, it does do an initial round of validation first, make sure that all the inputs that I have given are passed, and then I go ahead and click on create. So this is something which I typically do in the portal, right? Now on the right side, you have another option which is called downloaded template for automation. So what happens here is when you do this create, basically you are submitting this deployment request to Azure. In the backend, this UI is actually submitting an ARM template, an Azure Resource Manager template for automation or for your resource deployment, right? So once I click on this download template for automation, what I would see is there, like this is the template file that I see. Now I just asked for a virtual machine, but you see here there are multiple resources or things it is trying to create, right? So let's see what those are and have a look at this file. So it is basically trying to create a virtual machine. Now you can see 4 different components here. The first one stands for a network interface card, the second one for an NSG or a network security group, third one for a public IP address, and fourth one for the actual virtual machine as such, right? So these are the 4 minimum components that you require for your virtual machine. So this public IP is not mandatory, but because in the options that I took, selected, public IPs and NSG was selected, that's why I got this option, but otherwise this is not mandatory. So at the bare minimum, you need this NIC and the virtual machine as such, right? So these are these 4 resources, which I already mentioned. Now let's see what happens when you are submitting this particular ARM template, right? So what happens in the backend is when you submit this template to the Azure Deployments API or the resource provider, right? This template gets submitted to something called a deployments runtime. So this is where you initiate that with a command. If you're familiar with AZ CLI, you can use a AZ deployment create to create an ARM template, or even it's the same thing when you're doing via portal also when you click on that create or submit button, right? So it's essentially calling that ARM deployments API and passing this payload or this particular configuration ARM templates to the deployment API, which in turn will transfer it to the deployments runtime. So once this gets submitted to the runtime, which is ultimately responsible for evaluating your template code. So it basically does check all those different parameters that you have passed, and it will look into all those validations, and then it passes to the specific resource provider. So in this case, it will pass one information to the network card resource provider, the other one to the virtual machine resource provider, etc., depending on how your configuration looks like, right, or what exact resources you want to deploy. Now, this is the place where most of the validation and all those magic happen. So let's see what happens here exactly. So when you actually submit a template to Azure, there are several steps to check that we go through to ensure that the best of in our best effort to make sure that the templates will get succeeded, right? First, it will do a syntax validation. So in this example, you can see it should have had a resource group dot location, which is missing. So that's why it is giving me a syntax validation. Then it looks for a pre-flight validation, which is a little more advanced. This is basically checking in to make sure that all the values that you are providing as part of your template or the form which you fill up as part of your portal, right? It's trying to create the same resource. It will also check like, okay, if there is a resource with that name already existing in the same resource group, or some like global resources with that name are existing, etc. So in this case, as part of the pre-flight validation, it's giving me an error saying that, okay, this particular app is not available because that name is already taken, right? So this is how this validation is getting passed completely, and then you click on the create, then it is getting transferred to different resource providers for the resource submission. Now, what's also another interesting thing here is another capability, what we call as what if, or like a validation, which we can do even after pre-flight, which basically does everything except deploying the resources, right? So basically, it will compare your ARM template to what exists already in Azure. So you know that if a resource is going to be getting created, updated, deleted, etc. So it runs all of those validation checks that happen during the actual deployment. So running WATF is actually a really good habit to see what gets created. So if you are familiar with Terraform and all, you usually do a Terraform plan right before you do a Terraform deploy to see what is changing, etc. So that's something similar. You get an option of what if. With that, you can see in this case, I'm getting this address prefix removed, and I'm getting this one added, and there are some change like this is getting deleted, etc. Right? So those things you can validate before you do the actual ARM template deployment. Now let's see how these various components are getting deployed together. So we have four resources that we are trying to get deployed, and you can see it here. So what Azure ARM templates will do is like it will always try to deploy maximum number of resources parallelly, right? But you need to also make sure that there are some resources which are a prerequisite for one resource. Say, for example, if you want to create a virtual machine, I have to create the network interface card first, right? So in this case, I have to have the first resource created, then only I can go for the first resources. But while ARM template always tries to pass these things parallelly for maximum efficiency, right? So now when you have this Azure templates or the ARM templates open up in your portal, you have an option to visualize, or even in Visual Studio, you get that option where it will show you what is the dependency. So in this case, I have the virtual machine subcomponent is network interface card. For the network interface card, it needs to have a VNet and a public IP address, right? So in this case, so this is the sequence of resources getting deployed. So first it will create that VNet and the public IP address, then the virtual network will get created. So now this virtual network is actually depending on my parameters of VNet name and the public address. So I need to have a VNet name specified. In my template, though I'm not creating the VNet name, but I still need to have that information passed on. I have to have the public IP address, then only my NIC card will get created. Now, once my NIC card gets created, then I have the VM getting created. So this is how you specify the sequencing. So in this example, it will look pretty simple, but just assume that you are actually deploying a complex environment with multiple virtual machines, web apps, databases, and things like that. So this depends on really helps you to make sure that while a lot of your resources can get deployed in parallel, there are some places where this specific sequence that needs to be followed. So finally, this is how your deployment would look like, right? So this is on a high level about the ARM templates. You will get multiple details here, like you can see in each, if any specific stage, for example, all these three passed and this one got failed, you can go and get the details of why this failed here. And you can always use this correlation ID if you are creating any support tickets and things like that for further investigation, right? So that's pretty much about the ARM templates as such. And I will quickly talk about Bicep and then have a quick demo as well. So Bicep is an additional domain-specific language that we have created on top of ARM templates. It uses the same power of ARM templates, but it's pretty easy to author and manage, especially when you have the right plugins as part of your Visual Studio Code and things like that. It is pretty easy to manage. So though we create Bicep in the backend, it's actually getting transpiled to an ARM template itself, right? So some of the advantages of using Bicep is like it's day one support for all the resource types and API versions. So whatever you have resources available as GA in Azure, you get that support via Bicep. It uses a very simple syntax. I'll show you that compared to an ARM template, which has a lot of JSON values there, right? Which may look a bit ugly, I would say, in my opinion, or a bit complex to read through. So the Bicep simplifies that. And I'll show you how that authoring experience is. And similar to the module functions that you have in Terraform, right? You have those modularity and things like that as part of your Bicep. And again, it's open source. There is no cost involved for using this. And you can still use this what if validation and other things with Bicep as well. So there can be one question like, hey, when things like Terraform and other things are very popular, why we are going with a different language altogether? So the idea here is like, while we always ensure to make sure that, or we make sure that we have the continuous support available for all Terraform resources from Microsoft, this is something we are providing for our customers as an additional language experience, where if you want to have infrastructure as code maintained in Azure outside of Terraform and other third-party components, right, or third-party ISE tools, you can still use the ARM template, but you can get that covered with Bicep, so that you don't get to author an ARM template as it yourself, but you can just simply write your Bicep code, and in the backend it will get transformed to ARM templates when you submit it to Azure. So this is what a code would look like. I'll just quickly show a demo and show you how this works. So these are some reference templates, some reference URLs where you can look for learning more about Bicep and ARM templates. With that, let me quickly switch over to my Visual Studio. Let me close all of this. So let me add a new folder here for demo. And let me add a Bicep file, demo.bicep. So this is my Bicep file. So I have the Bicep extension added to my Visual Studio Code. So that way this is detecting that this is a Bicep language, right? So the easy way for you to create a resource is something like resource. Then you give a name, say for example, VNet. Then you put something like VNet, so it will give you the virtual networks, right? You use the latest API version, right? And then this is all like IntelliSense will give you the next option, what you want to use. I can give it a name, then I can give it something like a location, right? Then I can give it something like properties. Under properties, I can maybe go with this. Sorry, I think I have to use the other places. Again, give my address space details here. I can give any additional information here, right? So there are multiple options. All these things I can easily author from my Visual Studio. So that's why I told like the authoring experience is pretty better. So you can do all these things, or rather there's a very easy shortcut that you can use if I want to use a VNet. Okay? See, I don't have anything created here. So I'm just typing VNet. I'll get this resource VNet. I just type that. So it is giving me an out-of-box VNet configuration, which has the bare minimum stuff it requires to run a VNet, right? So let's give it something like VNet 01 or something. I'm just changing the name for identification purpose. You can always pass on parameters and other things, which I will show as part of one of the GitHub actions that I have configured. So this is how your code looks like. So you would have noticed how easy it is to create a Bicep code, right? I'm just going and saving it. So now what I can also do is, if I go to CD demo, so I have this Bicep file. So if I do a Bicep build and with the demo file, I can actually create my ARM template here, which is not required. I'm just showing this only for this demo purpose, because you can always submit your Bicep file assets for the deployment. But here you can see in this case how simple or how different this is. Like while JSON comes with its own terms of syntax and a lot of things, the Bicep code is pretty easy and very easy to read and like interpret, right? It's more like a human readable format, while JSON is more for a machine readable format, right? So that's how easy you can create a Bicep template. And if you want to create an ARM template out of it, there is also an option to do the other way around. There is something called AZ Bicep decompiler, which is again in the best effort, it will try to create the Bicep templates out of the existing ARM templates that you have. Okay. So now let me try to quickly deploy this template. So let me do AZ deployment. Then group. I'm doing it for this particular. I already have a resource group created in my Azure subscription that is called Bicep test. And I am going to use this template file. That is my demo.bicep. So what I'm trying to do here is I'm trying to do a deployment at my resource group level using this particular resource group Bicep test with this particular template file. So let me it, fine. Easy template file demo All right, so I think I haven't given the location parameter here. That's why it didn't allow me. So let me do something. So it is using, though it is using the resource group location. List is all right. Okay, let me quickly check what it is. This is the RG. This is East West. Fine. All right, I think there was some syntax error which I did. So now this is trying to run, right? So it's a bicep. It's showing there's a new release available. I can ignore for that now. And in the backend now it is going to start the deployment, right? So while this is running, I'll show you how that output would look like. I'll also, in the best interest of time, I also want to quickly show you GitHub actions that I have configured. So if I go to this, and this is again available in my public repo. So I have created one specific pipeline as part of my GitHub action. So what I did first is, like, as part of my settings, I have created some secrets, which is used as my Azure credentials. My Azure resource group name and subscription are being passed on as secrets to this particular repository. And now here I have a bicep code, which is to deploy a storage account, right? And here what you would notice here, like, there are a few things like I'm taking the storage prefix name as parameter, right? So I can have I have hard coded this, but I can always override this with my pipeline parameters, right? So this is the bicep file. Now I will show you the action for the pipeline that I have created for this. If you see the workflow file, it's like on push any change to this code. It is doing a job of build and deploy. It runs on my Ubuntu runner as part of my GitHub agents, right? It checks out that the code from my root directory. Then it does a login to my Azure subscription using the credentials that I mentioned. So there I have my subscription ID, my like the service principals, user ID, password, and everything is part of the secret that I have stored. So that's getting used, and I do a login, and then I do the deployment, right? So this is where it is actually using your ARM deployment to use the bicep code. So these are few information I'm passing on to the template, bicep template, like my subscription ID and resource group name is something which I'm passing on as my my repository secrets itself. And I'm calling out this specific template file. I can even add my parameters here, like for the storage account name, any parameters if I want to override. I can actually show that in my history. If any parameter files I want to override, I can do those things. So yeah, so here I initially had those parameters. I used something for a different storage prefix for a different storage name extra. But yeah, so this is how that pipeline would run. So this is how you can utilize the actions as part of this pipeline. And let's see an instance where it has run, right? So it checked out the code, then it deployed that specific resources into Azure, and then it runs some post checks, and then it completes that job. So that's pretty how simple it is. And as part of the Azure Bicep documentation, you will get the steps to follow this exact pipeline. You can configure things by your own and try it by yourself. Now let's go back to Azure and see if it got those specific VNet provision. Yes, it is provision. I got to this VNet. You can see this got provisioned recently. And most of you would know, like any resource that I have in Azure, I can always export an ARM template. But this will be pretty difficult because of the machine generated ARM template. There will be a lot of places values would be hard code, and it would be using its own way of using parameters and variables, etc. So it may be a bit difficult for you to decode and use that. So it's always better to create those from scratch, or we have this Azure ARM templates, starter templates, part of like Microsoft documentation, which can be used for any specific ARM template reference. So now we have started updating it with the bicep code as well. So that is pretty much on the bicep portion and ARM templates as such. So any questions? I know I covered it in a bit hurry because of the time constraints, but I can stay back and answer any questions if you want. All right, let me have a look at the chat as well to see if somebody has a question. All right, if there's no questions, I think we're good. Thank you, everyone. And Rashmita.
Yes, Deepu, I'm not sure if you have answered that question. I think Ramakrishna has posted 2 questions.
Yeah, I think he has
I think
answered.
I think I answered the first one.
Yeah.
Second one, I'm just trying to get that link. Let's check here.
Sorry,
Okay.
fond request if you can give some article or any resource, as you said, to the chat box.
Yeah, that's what I'm trying to do.
Okay, great.
Also, if you do event check-in, you'll get all the related Learn module links, but I'm sure Deepu is also sharing.
Yes, I'm just trying to give that specific resource link, but definitely this is covered as part of our WAF cost optimization pillar. Give these links. Yep, I just posted it there.
Thank you, Deepu. Thank you so much.
Do we have any more questions? Okay, sounds like we are good. Deepu, thank you so much for doing the session, and thank you all for joining us today. Please feel free to do event check-in and do share your feedback about today's session. It will help us to choose our topics better. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming session. We have another session from this series on 26th October. I have already shared the meetup link on the chat. You can feel free to go there and do the registration for 26th October. Thank you all once again and enjoy the rest of your day. Thank you, Deep.
Thank you, Rashmita. Thank you, everyone. Have a good day.
Thank you, Deepu.
Bye, everyone.